All right, another kit. I like the looks of this one because it's laid out the way an engineer would lay it out, and we'll get to that later. But this is a FM radio, so normal FM radio broadcast. One of the nice things about this is it's all discrete. It's all single transistor, so you can kind of see all the building blocks of what goes into a radio, so I like that aspect of it. It's about $25, so it wasn't exactly cheap. This is the instruction manual that came with it. It's all in Chinese, which I can use my translator app to do things. And when it got to the part where I was interested, the schematic, it was totally unreadable, absolutely unreadable. So that wasn't going to do me much good. So I contacted the seller on eBay and said, do you have electronic copies of the files? And they did. And they were really nice, and they had no problem sending me the electronic copies of the files. So kudos to them. So the schematic that I couldn't read, I printed out first, and then I still couldn't read it. And so I printed it out again, big size. So I posterized it. And so now I can see everything, and hopefully you guys on camera will be able to see everything. So like I said before, if you just take a look at it, all you'll see is transistors. There are no chips, which is great. So we should be able to look at each functional block. So like this block down here, let's see. This is the audio amplifier, this section right here. So here's the speaker, here's a push-pull, and then the interesting thing of the push-pull is they're both NPN, but they've turned this, so this is a Darlington here, and they've turned this one into a fake PNP Darlington by putting a PNP up front and then driving the NPN on the back. Here's the biasing diodes for the amplifier to reduce the distortion. Here's the drive. This is a funny symbol here, but this is a potentiometer, so this is the volume. So they're going to generate the signal here, and then they'll pick off some percentage of that to get amplified, so that's the volume knob. There is some Chinese that I've deciphered. This is the FM discriminator over here, so this changes the FM into AM, changes it into an audio signal. There's an IF section. This is labeled mixer, and then we have the LO over here, and the preamplifier here. And I guess there's a ganged capacitor. These are ganged together. So this is like a pre-selector filter, and then the local oscillator gets mixed in here. Not quite sure how the mixer works. It's just they're both just fed into this point with capacitors, and then it goes on its merry way. So we'll take a look at that. So let's take a look at the oh, let's see, I did print out a couple other pages of it. There's a parts list, so that would be helpful. And then there's a section here which is in English, which is on how to bring up the radio and reception adjustment and stuff. So we'll be able to use that since it's all in English. Yay. Okay, let's take a look at the kit. So you can see the PC board is laid out like an engineer would lay it out. Like the LO section has a line around it and labeled LO. Here's the IF. Here's the FM discriminator, and then here's the audio amp. So each one has its own little functional block, which is really cool. This is be a really good learning tool for somebody. So yeah, I really like the way it's done, and it's all through holes, so it's easy to put together. Let's see what else we get in the kit. We get a massive speaker. So really, really an amazing speaker for a kit. So that's pretty cool. 4 ohms, 5 watts. Wow. Anyway, that's cool. Look at a bag of parts here. Here's the tuning capacitor. There's some inductors, some resistors and stuff. So look at that. Here's an IF can. I hope there's more of them. Oh, I see. Okay, so you get like a roll here, almost like an old leather tool roll. Ever seen one of those? If you ever owned a Jaguar. Anyway, let's see. I can roll this out, and all of the parts are on the layout here. Oh, that's really cool. And the IF cans are all different colors. So this one is blue. Oh, these are both blue. Good. So that one just fell out. It used to be there. So we will keep those in order because the different IF filters are labeled by colors usually. So we'll have to decode this. Anyway, that's a nice touch. Somebody took some time to do that. And then there's another one, another roll. Let's see what's in this one. This is just resistors. Very nice. It's all really nice. This would make a really nice gift. A really, really nice kit. So let's put this one together. This looks like fun. There's the name of the company. Zhaodan Ta Electronics. Okay. Audio, FM radio, 88 to 108 megahertz. Cool. All right, got the all the resistors on. I'm starting with the capacitors. The little ones first. They are also on a card. So I'm starting from the bottom up here, and everything is labeled so nicely. So I still need to figure out the color code of these things. I have a photograph from the website that I bought these from, and they had a picture, and I think it has the colors. I can see the colors of the different. There's 2 blues and 2 blacks and a red. So we'll have to figure that out. Anyway, on with the show. Do a what are these? 5 picofarad. Let's see here. 5 picofarad. And there's one up there, 5 picofarads. There's different types of 5 picofarads. That's interesting. Maybe they just ran out. So there's 1 of those and 2 of those. Interesting. Uh-oh. This is not cooperating. I'll do it this way. Okay, so these are all 5 picofarads. We'll figure out where these go. Isn't there? Okay. All right, I put the tuning capacitor on. I was going to put these coils on. They gave me some coils, but they're not formed very well. And there really isn't enough meat to put it through the PC board. And they gave me three 3-turns and 1 4-turn, whereas the board calls for 4 4-turns and 1 3-turn. So I went ahead and used their 3-turn for the LO. But the front end requires 4-turn and 4-turn, and I only have 1 4-turn, and I don't like the way it looks anyway, so I'm going to go ahead and make my own 4-turns. I've got a big spool of wire here. I picked this up at a flea market, I think, for $1, and it's a real screamer deal. Okay, so let me. So I just found something about the right diameter, and you know, just take a chunk of wire and we'll wrap it around and don't get it crossed. Anyway, you know, something like that, and then you can always form it. And got to scrape off the enamel so you can solder it down. That was the problem with the ones that they gave me. There wasn't enough meat to have a nice long lead to stick through the board and scrape it off. So so this will be a lot better. So I need 2 of these. I'll make another one. Okay, it's all together. Let's give it a try. I did turn it on and nothing happened. So my first test is going to be injecting an audio tone like we did before on different radios. So this is the amplifier section, and the output of the discriminator ends up being audio that feeds this. So if we touch over here, you can see we're getting a nice tone. And this circuit has a couple adjustments in the audio section, and they seem to be setting levels on the amplification. And so what you just want to do is you want to adjust these until you have minimum distortion. So there's distortion, right? It's clipping. So that's pretty good. And then this one over here, kind of the same thing. It has some sweet spot where the distortion is low. So I just adjusted those. I don't know if I did it right, but it's acting as an audio. It's acting as an audio amplifier, so I'm happy with that. So now you need to get the rest of the radio going. And I'm not quite sure what's going on here. I don't know what the IF frequency is. I do know what the input is. It's FM band. And so let's check the LO, see if that's working. We can do that with the spectrum analyzer. So let's turn that on, get it warmed up. Okay, so I'm going to use my near field probe. I'm going to put it over here next to the LO. It's marked on the PC board, so you kind of know where it is. So let's go take a look here, and I see something. So let's, we know the frequency is going to be around 100 megahertz. And let's do a span of, let's say, 20 megahertz, 50 megahertz. So there we go. And then I'm going to adjust the tuning capacitor, and we'll see if the LO moves or not. Oh, it does. Okay. So sorry. I just had some candy. Some Smarties. So anyway, that works. So what frequency are we here? Peak search. We're at 111 megahertz. So if we have a 10 megahertz IF, just assuming a lot of these things are designed for 10.7. So 10 megahertz. Yeah, that's right in the right adjustment. Let's go down to the very bottom. Oh, it kind of drops off there, so we can get down to about here, and that is at 100. So that allows us to tune down to 90 megahertz. So that's pretty close to the bottom. Might want to adjust things a little bit later. And then the upper end is over here, and that is at 124, so that'll get us up to 112. Yeah, so it's a little bit high. I think 118. It doesn't quite cover the entire FM band, but close enough. We'll be able to get some radio stations. So we'll set it here somewhere in the middle. Oh, I just moved my probe. That's all I did. Okay, so we have that going on. I have an antenna hooked up, but it doesn't seem to be picking up anything. Or it might be, but I just don't know. So I think what we'll do is we'll inject a signal that we know of, and see if it goes through, and go from there. So let's hook up a generator. All right, made some progress. So right now I have no signal coming in the antenna. There's nothing coming in the antenna other than regular radio waves, I guess. But the local oscillator seems to be working. And poking around in the IF section, which I don't understand yet, there seems to be a signal around 11 megahertz. I'm not sure why, but there it is. And it stays solid no matter what tuning I do, okay? Now I can get it to move up and down with this one. I can get it to get big and I can get it to get small. And when I twiddle this one, I can get this frequency to shift back and forth. So there must be a local oscillator in here that uses this as its oscillating. So I'm assuming that that's the IF, and that's what it wants to do. And it seems to be at 11.2 megahertz. Okay, so I thought, well, let's see if I can get the rest of it to work then. So I have gone over to the function generator, and I've set the function generator at 11.2, 700 hertz FM modulation, 15 kilohertz deviation. Should be something like a radio station, I think. But it's at the IF frequency, all right? And then I figured out where the discriminator was, and I can inject it right here. You hear that? So I'm able to get something through the circuit. There we go. And I can twiddle these knobs here. So these seem to be the filter that you're doing the slope detection on. So they're clipping there, feels like. And this one doesn't seem to do much. But this one, oop, jumped out of my hand. That one seems like it is doing the slope detect filter. It is awful raspy. So I might have too big of a signal right there. Anyway, so I claim that the FM detector is working, the LO is working, the audio is working. Now I just need to get a signal through it and get that to work. Okay, well, it is very finicky. So, like I said, I think the IF is 11.2 megahertz, so I have 100 megahertz coming in that's modulated. I set the LO to 111.2, and I can get some sound out of it. And if I move the tuning knob, it is very touchy. Then I can tweak things up. So I can tweak this one, and I can tweak the filter. The filter is quite sensitive. And I think if I disconnect my signal and let me turn that off. All right, I think we can receive radio. Let's try. There we go. Wow, is that bad? Oh. Anyway, I do have a working radio. I don't want to get violated on eBay. I mean, YouTube. So, there we go. I think it'll just take a lot of tuning to make this thing sound right. But it does seem like there is a... All right, so let's back up. So if you're going to build one of these things, you're going to need some test equipment for sure. It's going to be tricky. So this is not for the faint of heart. So let me run you through all of the steps that it took me to get this thing up and running. The first was debug the audio. Make sure you can send audio out, because if you can't hear it, you can't hear it. So get that working first. I injected my audio signal right here on this pin here. Okay, so I sent in a 700 hertz tone. And then I used a spectrum analyzer to make sure my LO was working. The LO should be 11.2 megahertz higher than your receive frequency, right? So make sure your LO is working. And then, what did I do? Let's see. Then I said, well, okay, let me measure other things. So I brought, without anything going in the antenna, I just went around, and over in this section here, between these two cans, I think this can here, there is an 11.2 megahertz oscillator, at least in mine there is. And if you adjust this blue one here, it seems like it changes that frequency, and you can peak it. So what I did was I peaked it, so I got the maximum amplitude, and I didn't worry about what frequency it was. I just made sure it was the maximum amplitude, and that turned out to be 11.2 megahertz. So I got this one working. And then I watched the IF here out of the orange one here, and I peaked it so that my LO was leaking through at a high level. Okay, so I kind of peaked that for maximum. I was probing around here, and I peaked this to tune it to the LO, and then I got all that working, and then I said, okay, I've measured my IF. I think I know what that is. So I injected the IF onto this diode right here. And I injected an FM modulated 11.2 megahertz. And I tweaked these until I got sound through. So then I was at least getting sound through. And then I said, okay, I'm going to inject a signal onto the antenna. And the way that I did that was I took wire and I took my clip lead and I clipped it over the insulation. Okay, so that's how I was able to get a signal into the wire without upsetting anything. I didn't want it loaded down with 50 ohms. I just sent it through the insulator. And then I tried to get everything working. It took a little bit of finesse to get the first sound through it. I had to change the tuning, I had to change some of the cans and stuff, but once you get something making sound, then you're in better shape. And then everything is relative in there, so you make very fine adjustments, and you don't want to move away from the radio not doing anything at all. And so you need to start tweaking it. I didn't have to tweak any of the coils. What I did was I made my own 4-turn coils because they only gave me 3 turns. So I made my own 4-turn coils. They give you this 48-turn coil and they give you this 3-turn coil, but these two I made myself. It was missing 2 capacitors. It was missing this 10 microfarad and this 10 microfarad. All the other components were there. I put on just a couple feet of wire as an antenna. And yeah, wow. So I didn't expect this one to be so difficult, but I still like the way it's laid out. I like the way that the engineer who designed this was thinking. You know, IF was labeled, LO was labeled, frequency discriminator was labeled, audio was labeled, and they're separated, so they're easy to figure out where the things are. The front end's a little bit crammed, but that's okay. It did help to put a really healthy signal in. I wasn't putting enough signal in the antenna, my 100 megahertz tone. I wasn't putting in enough originally. When I was putting my spectrum analyzer around here, one of the local radio stations was actually louder than my 100 megahertz. I could see it just on the spectrum analyzer. And so I increased mine to swamp everything. So that helped a lot, having a really large signal in there, even though it's distorted or whatever, at least getting a signal through that seemed to do all the down conversions and detections and stuff. So that helped also. All right, so would I recommend the kit? Only if you are well advanced, understand radio theory, have enough test gear, and have enough patience. It is not an easy kit at all. I believe it is achievable for a lot of people, and not achievable for, I'm going to say 75% of the people aren't going to be able to build this because they don't have all of the test equipment that's going to be necessary. Not that you couldn't. I believe probably people have built this thing without any test equipment, but it's going to be tricky. Definitely helps to have ways to inject signals. I haven't really. I believe that you could probably use the either the nano VNA or the tiny SA to generate signals with. I haven't tried that. At least the tiny SA has modulation available, so I think you could probably, that would probably help you out here, and its spectrum analyzers functions would help you out here. Would I want to use a tiny SA to build this board? I don't think so. I think it will be quite painful. But if it's all you got, it's all you got. Hey, I started out somewhere. You've got to start out somewhere. I'm going to use my good tools if I have them. Why not? Especially for something like this where it could use it. So it's $25. And it's well documented as far as the parts are concerned. It's very poorly documented when it comes to you. There's a Xerox copy that really doesn't do you much good. I did ask for electronic files, and had I not had those, I don't think I would have accomplished this. So I was able to get a schematic that I could read. The board does not match the schematic. Yes, that's true. The board does not match the schematic, but in a very, very small way. Almost everything is correct, except for this pot here. This 2K pot doesn't appear anywhere on this diagram. And so this is the audio section, and you can see that there's 3 diodes here to bias this. And then there's a pot here that biases the base of this transistor. Well, that's on here. That's the 50K. That is on here. It is wired up. But there's only 2 diodes on my board. There's not 3. There's only 2. Okay? If you look right down there, there's only 2 diodes. And then right next to those 2 diodes is this 2K pot. So what they did was they eliminated one... They eliminated one diode and they replaced it with a 2K pot. And so you can change the resistance of this chain. It's got a couple diode drops, and then you can adjust the current through this leg with this 2K pot that's right here. So that is different than the schematic. Everything else I think is true to the schematic as far as I've seen so far. And so I hope you've enjoyed the videos. And if you buy one of these, maybe at Christmas time, and want to build it, hopefully this video will help you with my methodology of how to get it to work, and maybe some tips on getting it to work.